So I'm going to start today's talk by asking you a set of yes or no questions. And if your answer is yes, then you raise your hands like this. Okay, I know this is the last talk. Raise your hands like this, okay? So raise your hands if your tests are automated. Come on. Yes, I see all the hands up, so that's good. Awesome. Now raise your hands if your tests are executed on a daily schedule basis. Awesome. Again, most hands up. Now raise your hands if your tests are a part of your CI build. Awesome. So now that we know all of us rely on our test results to a certain extent, let's see if we're able to relate to this story. And these are the characters of our story. We have a manager, we have a couple of developers, we have a test engineer and a test automation engineer. So at this point, the test automation team has just automated most tests, and the developers are starting to see the value of automation, and they're very happy to see quick feedback, and they're all glad that they have automated results. So you see they're very happy, they're all smiling, because they're still seeing value out of automation, they're still happy. So the trust meter is very, very high at this point. Now they see a test failure. Ideally, every new test failure would be due to the latest change that the developer makes, and then the developer would focus on debugging these failures. But one fine day they see a test failure, and the developer goes to see where's the bug. He tries to look into the code to see if it's a bug that he introduced with the latest check-in. But he's not able to find the bug, and then the automation engineer goes and takes a look at it and says that, hey, it was actually a false negative because of an automation bug. So now the trust meter is kind of very neutral, not too good, not too bad, because they actually saw a false negative and wasted so much time on trying to debug that. So this happens all over again, and now the trust meter is very low. So one day, when automation actually caught a critical bug, they kind of ignored it, thinking it was just another automation bug. I mean, you can't blame them because this has happened a couple of times. So when this happens as an automation engineer, we feel bad that our test reports are not being trusted. So what do we do at this point? We just have to take a step back and try to build the blocks of trust in automation, and that brings us to today's topic. So before we move on, a little bit about myself. Yes, my phone says that's me. So I'm a test automation engineer, and I've worked in 3 companies in the stage where they just transitioned from manual to automation, and so dealt with a lot of trust issues, and like having the teams to actually trust the automation and adopt it in their day-to-day lives has been the biggest problem at my job in all my 3 jobs. So this talk is about my experiences with that. And if you have some strategies and tips on dealing with some situations, please contact me after the talk, or you can follow me on Twitter and contact me on Twitter, or connect with me on LinkedIn. So introducing the blocks, we'll be talking about reliability, collaboration, and visibility in detail, starting with reliability. So what is a reliable test? When a test that is consistent and stable in measuring what it is intended to measure, that's a reliable test for us, right? So looking at it with an example, in a control environment, when we make assertions against an expected output, right? And for example, if something exists, perform action delete on that something, and verify that the output is that something deleted. So when we verify that the output is that something deleted, if it passes, it's a test, the test passes. If it's not that, the verification doesn't return that, then the test fails. So that is an ideal test for us. But at some point, when our test just doesn't go through the phase of performing an action, it just stops there and it times out, and then we get a failure. So at this point, our failure is not because the test went to the stage of verification and the output did not match. It's because there was a timeout and it was just a flaky test, right? So this is a non-deterministic test, and we deal with a lot of these tests. So what exactly is a non-deterministic test? It's a flaky test, and sometimes flaky test is synonymous to UI automation, and many people kind of consider it to be normal. And it's the single most killer of trust in the world of UI automation. And what really causes flaky test? There are so many reasons that cause flaky test. Mostly it's the infrastructure, asynchronous calls, test data, and a lot of automation experts have spoken about it, blogged about it, tweet about it. So we've heard of this a lot. So in today's talk, we'll be looking at what measures we took to overcome this situation. How we deal with flaky tests is identify, isolate, and investigate. So we first try to identify the flaky test. We look for a pattern. So try to look for a pattern of the failed test that were not due to the real bugs. For example, maybe all of the tests that failed had a specific user role setup. Try to look for a pattern. And then spot the flaky test and note them down. That is our first step of identifying the flaky test. And then we move on to isolating the flaky test. So once you identify, isolate them. So one way of implementing isolation is by adding tags. Tag the flaky tests to keep the main builds clean of the flakiness as much as possible. And then you look at all the tagged flaky tests and work with them every day till they build successfully for many builds. At this point, I know there may be many concerns as to what if it's a critical functionality test that is flaky? Do we remove them from the main build? What if you succeed, like if you just check in the code without actually testing the critical functionality? So if that is a concern, we have to talk to the team and make sure that you tag them and have it available still in the main build. That way, when your developer sees it, he sees the test is tagged flaky, so he'll try to rerun it a couple of times before checking it in. So that is about isolation of the tests. So this is an example of how you can tag a flaky test in spec flow. Every test runner has its own different ways of tagging. And then you investigate the test. You do a post-mortem analysis of the test. If this issue is because of the test or actually the environment, you try to figure out the root cause. So when we look for the root cause, so it's not always the test, right? It could be so many other factors other than the test. It could be the test or the environment. So you start looking, if it's the test, then is it because of a concurrency issue? Is it because of a caching issue? Is it because of the test size? If the test is too big, sometimes it causes some flakiness. And if the test is dependent on some other modules and it's waiting for that, it's going to cause flakiness. And then are there sleeps in the code? That's a very common topic. And if it's a parallelization issue, and so much more. So you first look at if it's the test, and then look for ways to fix that in the test. If it's not the test, then if it's an environment issue, is it one of your Selenium grid nodes that's not on, it's failed? And then do you have some network issues, server issues, database issues, resource leaks? Or is there an actual bug in the framework, in the version that you're using that you updated? So there could be so many issues. So figure out the root cause and then look for the reasons why it's failing and try to fix them. So after you do that, after you fix them in your flaky build, then you observe the test for a number of times. If they are passing for a long time, maybe like for a few days, if they're constantly passing without failing, then you remove the tag and put them in the main build. And that kind of helped for us. So I'm hoping it'll help for you too if you're not following this. And then, so that was about damage control. What do we do when we have bad tests and flaky tests? So now we look at how we actually try to write really good code such that we don't fall into the flaky issues because of test scripts. So we follow, like we have a Jira board, and we have the review tab set up by default so that we treat our test automation code just like any other software code. So when it goes to the review tab, we follow a code review process. So initially, when the code is committed to the repository, there's a pull request created for the commit. And then we document the pull request in the Jira ticket and add it to the review tab. And then once the developer takes it from there, we check if that ticket actually has a framework update. If it does have a framework update, then all the automation engineers have to take a look at that code for reviewing. And then if it gets approved, then it gets pushed to the master branch. If it is only a test script, it doesn't have any framework updates, then only one automation engineer takes a look at that, and then it goes through the approval process, and if there's any change required, then it follows the cycle all over again. And then when we actually do the code review in the machine, we pull down the code, we compile and build, we review the code, and we run the test multiple times to make sure it's not flaky. I know some people have like something written just to run the test like 10, 20 times before they check in the code. So you can do it however you want, but make sure that you run the test multiple times to make sure that you're removing the flaky factor while doing the code review session itself. And then we even check in the CI integration if it is successful to make sure it's not flaky. So this is the code review process that we follow. And then while actually doing the code review process, we make sure that the definition of done is satisfied, if the test coverage is good, if the test description is accurate, because again, treat automation code like software code. This was told by many of the experts, and we try to follow them as much as possible by following some good practices. So that was about reliability, about making sure that we have reliable code and we trust the test scripts that we push in to make sure that we have good, reliable test scripts. Next, we move on to collaboration. So as automation engineers, usually at least in small companies who are just transitioning to automation from manual testing, we usually work solo or in very small groups. So being an effective automation engineer usually means being effective at building key partnerships to open up new opportunities and to actually have people adapt to automation and use the work that we are building. So collaboration is very, very important for us. Usually, sometimes with the best intentions, the automation engineers often pointed towards the goal of automating everything, automating all the regression, the UI that's available. But we have to make sure that we make good decisions and we automate the right things, whatever it may be the right thing is for us and according to the application that we are planning to automate. So we need to have a good strategy behind it, right? And it's important for us to discuss the strategy with our quality assurance leaders and to have a key partnership with them because they are going to be like the gatekeepers for the work that we will be fulfilling, right? So they'll be among the most valuable advocates of success to ensure that we're automating the right things. So we need to take time to talk to our leaders about our automation strategy, what makes for a good automation candidate and what doesn't, and we need to share the important reality that once automation is built, it needs maintenance too. You cannot just build it and move forward. You have to maintain it. So you need to make the right decisions before automating to make sure that it's good. So that is why having a good partnership with our quality assurance leaders is very important for us. That's the first step towards collaborating with the right people. Next, collaboration is going to be with the software developers because 2 points, design for testability and knowledge sharing. So discussing testability in the early stages itself helps with them thinking in terms of testability when they are building the application so that it's easy for us to actually work on automating it the right way. Sometimes I've even gone back to our developers and told them, hey, I'm not able to automate this very well. Would you be able to change something up? And they have been open to working with us based on that. So it's important to have good partnerships with our software developers. And for knowledge sharing, for example, like one of our dev teams at my employer shared information about using Power BI to visualize some of the sales data reports that they were building. And this gave me a new insight towards a tool that I could use for automation. So I used Power BI to actually visualize the test automation reports. And also our dev teams were using AWS, and we were evaluating AWS for our Selenium grid efforts. So our learning curve became so much more easier because we collaborated with them and kind of got some information from them on some security and this and that they already spent so much time researching. So that is why it's important to have a good partnership with our developers so we can leverage their expertise and kind of use it for our advantage. Next key relationship is with our test engineers. So we all know that our test engineers are the subject matter experts, right? And they understand the different personas that are likely to use the application, and they understand the different user roles and critical scenarios of those roles. So they are really an asset. So we as test engineers, test automation engineers, will gain so much by working hand in hand with them. So, and also, usually in companies, test automation engineers are just directed to automate the test of an application, but they're not really given any manual tests to base the automation on. So building great partnerships with our test engineers will help us create the automation that actually tests the application. For example, we use spec flow with Selenium C#, so we have test scripts and step definition and page objects and all that. So here is where we took their help. So what happens is the test engineer will identify the critical test cases and include step-by-step details, which then gets translated into meaningful test automation steps. And then we as automation engineers will verify and select the critical tests that are good candidates for reliable test automation. So, we trained them. I mean, we had some knowledge sharing sessions where we all practiced together to write good feature files because they were going to write the test cases as feature files. So since we were all collaborating together on writing feature files, we had to make some standards on how we were writing feature files. So we made it more behavior-driven, that is like to make sure that one scenario covers one behavior and some good practices like that around writing feature files. And then we phrased the steps all in third person and title. The scenario will communicate in one concise line what the behavior actually is, and some good practices around feature files because we were all going to use the same feature file, so we wanted to maintain the same language that we were going to use around it. So Tidy Gherkin is a Chrome app, which is very easy to install, which is something that people use to write BDD Gherkin language kind of feature files. We usually write feature files using Visual Studio or an IDE. Sometimes for our test engineers, they don't have the time during their schedule to actually learn a new IDE. They have a different skill set, which they're very proud of, which is very important to us. So sometimes when we want help from them, it's easier for us to get help from them when we introduce tools that's easy to work with. So we introduced Tidy Gherkin to write feature files. They will use Tidy Gherkin and write feature files, attach it to the tickets, and we take it from there and use it for our automation. So this is a demo of Tidy Gherkin on how easy it is to just get a template of a feature file. I know it's too small, but are you able to see it? Okay. So it gives a good template of a feature file, and then you get a scenario template by just inserting it from the tab. And then you can see that you can actually edit it and tidy it and add tables. This is how you add tables. You can just insert the columns, how many ever you want. And then you can select all of them and click tidy. It tidies up the entire thing. And then here you can see that you can actually create even step definitions in Java, Ruby, and JS. And then you can just save it as a feature file. So when you open this feature file, you can open it in your Visual Studio and go on with your framework. So in this way, by by having our test engineers help us by writing feature files. We reduce the step of having to frame test cases, which we might sometimes skip the most important test cases, but they are there to cover us, and this kind of helps us. So this collaboration was very, very useful for us, and it led to many good practices. So obviously we had our test engineers help us, and it's important that they understand the entire automation strategy that we use. So we had knowledge sharing sessions on explaining them the workflow of automation and hands-on test execution, where they can just go execute the test sometimes if they want to debug and contribute more towards automation by moving towards writing step definition files or actually working towards page objects. Most of the time we had most of the step definitions already covered, so when they wrote feature files, it was already covered in the step definition, so they were very happy when they could see that they're actually building automation that we could use right away. And then we had introduction to BDD, troubleshooting and evaluating automation bugs, and some knowledge sharing sessions like that completely exposed them towards automation, and it helped us a lot in the collaboration. So remember that we are all working towards the same goal, that is release bug-free software. So collaboration is key, and it helps a lot, especially when you're alone in the company as an automation engineer. It helps to have such key partnerships to help perform your job better. So we saw reliability, collaboration. Next, we're going to move on to visibility. Just a second. Yeah, so visibility is important for us because it's easy. It's nicer to get quick feedback, and quicker feedback you get, the easier it is to fix the failures. So we went for a user-specific metrics dashboard approach. That meant not everyone is interested in seeing all the results. The more information you give, the more confused they are. They just don't want to open it, because again, here we're dealing with the trust issues, and we're dealing with situations where we want to attract people to start using automation more and more. So we went with a user-specific metrics dashboard, where we have a dashboard specified for people based on what they do. For example, our manager would be interested in seeing metrics like server performance, or response times, and overall, like how the tests are doing, what the application status is like. And our QA engineers would be interested in stuff like which part of the application is actually failing, and where it's failing, what step is it actually failing in. And our test automation engineers would be interested in stat trees and information details like that. So we wanted to make a user-specific metrics dashboard. We used Power BI to do that. Usually, before, it just took us a lot of time to dig into each of the application reports for a long time. Every morning, we would spend most of the time trying to dig into each of the reports. So when we created this, we had all of them just in one screen. So the place where you see the errors, bugs, you could just drill through to go to the next screen, where you actually see the stat trace and the output of where the test failed and what exactly failed. So this is the view of the test automation engineer, because we would be interested in seeing this. The QA engineer, devs, and our managers would have different views that is of importance to them. You can also build your own dashboard. There are so many applications that you can use to build your own dashboard, like Datadog, ELK Stack, Grafana, Jenkins, Tableau, Power BI. Tableau, Power BI are very similar. Prometheus, reportportal.io, and you can build your own dashboard. The point is to have an easy way to visualize your data. So this covers all of our blocks on reliability, collaboration, and visibility. If there's something that I'd like you to take from this talk, it's basically to not ignore your flaky tests, deal with them when you see them, and then invest in key partnerships to build better automated tests, because that is very important. Get creative with your test result visualization. So one of the biggest testing mistakes we can make that that will limit the scalability of agile movement is basically getting accustomed to acceptance test failures. So can we make this level of transparency in results a reality where we're able to see a test failed and everyone's notified and they work towards building it immediately. Similarly, when a test is successful, we want everyone to be notified and be rewarded for it immediately. So this is what we want to achieve by following some good practices. That's what this talk is about. Thank you so much for patiently listening to me during this last talk of the conference. I hope you enjoyed the conference so far. Thank you.